basically we have 5 different things that you need at least to know the transformations of. What are transformations? Do you remember it quite vividly? Ava Wyrick, what is a transformation?
It is a change, like in flipped or shape.
Okay. It's the way a shape gets from one place to another. Or the way a shape changes, I guess. Okay, and basically you need to know these 5. Okay, there's the mathematical term I've always given you, and then there's like the generic one. The first one the book gives, if you have a rectangle, which that isn't, if you have a triangle, and it is its mirror image, we call that a, Emma? Yeah. One thing you can do is reflect, okay, which is a mirror image. We did this last year, so I don't think I'm going to spend, this isn't really part of the whole deal there. Another thing we have is if you have a triangle and it ends up being in the same general thing but just moves like this, I like to call that a slide, but that's not the mathematical word for that. When the thing shape just kind of slides over there, it is a translation. We call that basically the slide. Okay. If the shape, which I did not have in here, but the beauty of the bicameral system if you have a shape, let's say it's still that same triangle there, and it gets turned, so where it looks like this, I'll give you little guiding arrows here. About this point right here is the center of that. That is a rotation. Right, a rotation. Which basically is nothing more than a turn. And then sometimes you use translations for a couple different transformations. For example, if your triangle starts out like this and ends up like this. Okay, you always want to take a look, especially if the shapes are relatively close in what they look like. Okay, make sure you look for the telltale signs like where the right angles are. This shape has gone from here, love it, to here. In order to do, Mrs. Leadham!
Mr. Hahn, I hardly recognized you the other day when I saw
Yeah, I'm
that.
waiting. My thing is, I hate it. I'm waiting until it's 50 degrees out. Once we hit the 50 degrees, it's all coming up.
I like it myself.
No shape of
I need an 8th grader who's willing to sell me 4 suckers.
Well, this is an 8th grade.
I know, but I'm gonna leave it with you
Oh,
to
okay.
deliver the message. I need 2 bubble gum, 2 cotton candy.
Oh boy, 2BB, 2CC.
Do you remember?
I'll put one right here.
All
And
right.
it gets delivered where?
I'm 2nd grade today.
BBCC.
You won't remember.
2nd grade.
All right, you guys have to remember. Go ahead.
Do you have time that we can ask one quick question for an English paper?
Actually, I don't.
Okay.
Can you check in the office?
No, like, can I
Does it
ask
have to
a
be
question?
me?
Wow.
How long is this going to take?
No, it's
Like 10
class.
minutes. Or not 10 minutes, like 30 minutes. Okay, like can I ask it? Okay, who here, if you had a choice between Pizza Hut and Little Caesars, who here would pick Little Caesars? Wait, and who's the other one? Okay, you guys,
Pizza Hut or
ew,
Little
you guys like
Caesars?
Pizza Hut?
Oh,
That's
disgusting.
No, who likes Little Caesars over Pizza Hut? Who does not? Okay, how many kids are in this class?
28.
28, okay.
27.
Don't mind Mr. Hodges. Thank you.
Wait, that wasn't 3 minutes. These kids were
Miss Brown, what would
expecting.
you prefer, Pizza
I
Hut?
already had Little Caesars.
Okay.
Oh, yeah.
I have questions.
Now we know, Kendall. Okay, to go from here to here. Who's got, what needs to happen there? Gabe?
A reflection, then a translation, then a rotation.
Okay, really you need all three. It doesn't matter what the order is. Okay, but this is, first of all, it's been slid. Well, let's do, rotation would be what I would think first. Maybe if you rotated it this way, okay, the thing's gonna end up looking like this. Here's my,
I would be, that would be,
rotate it it would look like this. Here's your rotation, it's spun this way. Then you could slide it so that it's right next to this thing, it would still be looking like this, and then you would flip it over on itself. So rotation, reflection, translation. The order doesn't matter because you can do it in any way there. Now, in addition to those three, we need two more. Okay, two more of them. One of them is a contraction and one is a dilation. One is a contraction. Okay, and the other one is a dilation. And I guess if you're thinking about, we talk about these sort of things when you talk about having babies. Gals have contractions, and that is the tightening up of a muscle that's getting ready to push the baby out. Dilation means that mom's getting bigger so that the baby can come out there. And that's what this means. Dilation means, well, it's a fact of life, kids. It's a fact of life. Getting bigger. Contraction means getting smaller. But you have to remember the point, and it isn't just that they're getting bigger and smaller, it's that they're getting bigger and smaller proportionately. And the way the book kind of shows it is like this. If you have, let's say you have a, no journalism today. Okay, let's say you've got a triangle here. If you want to show a dilation, if you want to get something to expand in a bigger way, put a point out here and draw from that point a line and extend it from each vertex. In other words, do this. Go to this one here. Go to this one here. I missed it a little bit here. But if you take and then make a new shape, see this line, a parallel line to this line, if you make that new parallel line right from here to here, you make this distance from here to here the same as this distance is from here to here, you will get a dilation of this shape that is in proportion. Handy, isn't it? Or if you go the other way, let's say you have this shape here, and you take each vertex of that triangle and draw, I should have done it for a second. Let me do it over. And draw it to a point over here. Make it the same point. See, I like a vanishing point. And then you draw some parallel lines here. This new shape that you have right here will be similar and in proportion, and it would be a contraction. Okay? Now, a lot of times when the book labels these things on shapes, they will do something like this. They'll put this as point A, point B, and point C. In order to keep points that are corresponding, which means the same point on point A as on this one, they'll do something, they'll put a little hash mark over here, which in math looks like the foot sign if you're using numbers. In math, you call that prime. In other words, if I were talking about this point right here, I would call this point there A prime. This would be B prime, and this would be C prime. It shows that it corresponds to C, but because of that, it means it's not the same exact one as C, because it isn't the same, but it corresponds to it. It's a way to keep yourself organized so you don't have to do B's and Z's mixed up with each other at this moment.
For the smaller triangle, one that you just demonstrated, is there any fancy names for the A, B, and C there?
No. Well, that's kind of the bit, no, not, I don't think so. This is a world I don't delve into a lot, so I don't believe there's any fancy names, but fancy names may or may not be there. Alright. I got a piece of paper for you now.
Do we do a contraction?
I did a contraction. This is the contraction. Went from this triangle to this triangle. Contraction. We don't really have time to do what I was thinking. Yeah, I think I gotta stop there. 5 minutes is not enough time to read.